Okay, this is 5-5 trapezoid. This is the last section in chapter 5, the quadrilaterals and objective 5. This warm-up, I don't think we're going to have time to do this, so we are going to skip it, sorry. Maybe we can do it on the review day, I don't know, we'll see. Okay, so we are here, and objective 3, apply the definition and identify the properties of a trapezoid, I say trap, and an isosceles trapezoid. Right, so here's the definition of trapezoid. Trapezoid is a quadrilateral with exactly one pair of parallel sides. Okay, so just one pair. The other side is not paired. This is one pair, and these are not paired. The parallel sides are called bases. These are called bases. It doesn't have to be horizontal. It could be vertical, and still bases. And others are called legs. Okay, all right. And as you see, because these are parallel, these are supplementary, and these are supplementary. But because it's not parallelogram, these don't have to be supplementary. Same thing here. These are supplementary, but these aren't. Okay? And isosceles trapezoid is a trapezoid with two congruent sides. Okay? So one parallel and two congruent sides. Okay? And if you fold any isosceles trapezoid so that legs coincide, you will find that both pairs of base angles are congruent. So if you fold this, these angles can overlap. Okay, so that's one of the theorems. All right, so here is the proof for that one. Okay, so the base angles of isosceles trapezoid are congruent. Trapezoid A, B, X, Y. Okay, so on A, B, X, Y, and BX is congruent to AY, and we have to prove that X and Y are congruent, and B and A are congruent. So these are called base angles. Okay, plan of proof. Note the this diagram does not contain any parallelogram or congruent triangles that might be used. To obtain such figures, you could draw auxiliary lines. You could use either diagram below to prove the theorem. Okay, so there is one way to do it, is to draw this line right here, parallel to AY. So BZ is parallel to AY, so that, because these are already parallel, another set, and this will make a parallelogram. This is a parallelogram, and then how do you prove that 1 and 3 are congruent? And after that, you have to prove these are congruent. Okay? So I want you to do the roadmap here. Here's this another one. So you can draw these two lines. So that BP is perpendicular to XY and AQ is perpendicular to XY. And since these BA is parallel to XY, these are same distance, same lengths. These are same lengths. BP and AX same lengths by theorem 5-8. The 5-8 is the one that is, if the lines are parallel, it's equal distance, right? Distance between these two lines. This is distance because it's 90 degrees. Then it's equal. Okay, so I want you to think about how to prove this, and then we go over this in the class. But just to write down, you know, the plan of proof. So make these congruent by, and then, you know, that kind of thing. Okay, I think you can do it. All right, and here is a median of trapezoid. The median of a trapezoid is a segment that joins the midpoints of the legs. Note the difference between the median of a trapezoid and median of a triangle. So this is the median of trapezoid. It's the midpoint of the legs. The median of a triangle is the midpoint of the one of the leg, and then draw a line from the vertex to there. Okay? And so there is a related theorem here for the median of trapezoid. Okay, the median of a trapezoid is parallel to the base. So this is the median, it's parallel to this base. There are two bases, not just this one, they are both bases, right? So it's parallel to top and the bottom, and has the length equal to the average of the base length. So this plus this divided by 2 is gonna be this length. Okay, so that's given trapezoid with median, and then this is not isosceles trapezoid. Okay, it's just a trapezoid, and you have to prove. So median means these are midpoint and these are midpoint, right? But these are not the same lengths because this is no isosceles trapezoid. You have to prove that MN is parallel to PQ and MN is parallel to SR, and also the MN is 1/2 of this plus that. Okay, so again, this one you need auxiliary line, and you draw SN intersecting ray PQ at T. So this is the line you draw. Okay, so this one is a little bit of a toughie. So I'm gonna do the Plano proof here for you, and hopefully you can follow. Okay, first you're gonna make these two triangles congruent. So triangle SRN is congruent to triangle. So SRN, so that's TQN by what? Think about it. This is median, so these are the same, right? And these are vertical angles, right? And these are parallel. So these are the interior angles. You can do angle, side theorem. Okay, so if these are congruent, then if you look at this triangle right here, in triangle SPT, okay, M and N are both midpoint of two sides of the triangle, right? This is a midpoint because this is a, also I should probably write that, SN equal, that's distance, so SN equal TN by CPCTC, right? Okay, because these are triangle congruent and these are corresponding sides. So this is a midpoint of this ST, right? So then MN MN have to be parallel to PT, right? Okay, so MN is parallel to PQ. You remember, if you connect the two midpoints of a triangle, they become parallel, right? And since PQ is parallel to SR, and the two lines parallel to the same line, this is parallel to this, and this is parallel to this, have to be parallel in the 2D. So MN is also parallel to SR. Okay, so that's the one. Okay, now and then the two, if you think about it, MN is 1/2 of PT, right? Because this is half of this, because this triangle is connecting the midpoint, so the 1/2 of that. But 1/2 of PT, the PT, QT and SR are congruent, right? Because these are CPCTC. So SR equal TQ by CPCTC. Actually, it's not quite CPCTC, I'm saying equal. So strictly speaking, it should be this. And then you have to introduce SR equal TQ by definition of congruent segments. Okay, so since this is the same, and PT equal PQ plus QT, and QT equal SR, then I can substitute PQ plus SR, right? So then MN is 1/2 of, since PT is this, PQ plus SR, and that's what I have right here. Okay? All right, next page. All right, example 1, trapezoid is a median, trapezoid and median is shown, find the value of x. You can do this, right? So do this one for homework. And let's look at these practices. X, Y, Z are midpoint of the side isosceles. Explain why X, Z, B, A is a trapezoid. Well, we know that these are not parallel, and these are parallel because these are midpoints, so that's why it's a trapezoid. Name two trapezoid other than X. You can do this. Yes, we did the video. Name isosceles trapezoid and find its perimeter. You can do this. Okay, find the isosceles trapezoid. Hint, this is 10 and that's a 10. Okay, find the length of the median of each trapezoid. I think these are too easy for you, aren't they? Yeah, maybe just do this one. Okay, and let's see. Draw a trapezoid described. If such a trapezoid cannot be drawn, explain why not. With two right angles, with both bases shorter than legs. All right, so why don't you do odds for homework? Okay, and then we're gonna do 8 and 10. Right, so with both bases shorter than the leg, yeah, so I can do something like this. Both bases shorter than the leg. All right, with three acute angles. You have to have two sets of supplementary angles, right? To have a trap, no matter what it is. Like this is a trap. These have to be supplementary and these have to be supplementary. So you can only have two acute angles. So no, not possible. Okay, and we are done, I think. Yes, I may assign one of these for the video, okay? I mean the survey problem. All right, see you in the class.